All right, class. So today we're going to be looking at interpreting correlation coefficient. The correlation coefficient is the R value for the set of data that measures the sign and the strength of the correlation between two variables. Now, the correlation coefficient is a number that we're going to be finding that falls in between +1 and -1. And the closer to 1 that it is, the stronger it is, whether it's positive or negative. So we're going to look at the ranges that we have. So we have what's considered to be a strong positive. So a strong positive is going to be from a range of positive 0.9 to 1. And by it being a strong positive, we're going to color that in as a green. That green area let us know that we're within a strong positive. Then we have the moderate. The moderate positive is between 0.07 to 0.89. And we're going to color that area yellow to let us know that it's moderate. The next we have is going to be a weak positive. Weak positive falls in between 0 and positive 0.69. So that means all that area here, if the number falls within that range, is going to be considered to be a weak positive. Now we're going to go to our negative side of things. And the negative side is we have a weak negative. Weak negative falls in between 0 and negative 0.69. So we'll color that area red as well. Then we have a moderate negative, which falls in between negative 0.70 to negative 0.89. So we color that area yellow. And then we have our strong negative, which is negative 0.9 to all the way to -1. So we got to remember that when we find our correlation coefficient, that it falls within a range between +1 to -1. Depending on the area in which it falls, it will either be a strong positive, moderate positive, weak positive. Or it could be a weak negative, moderate negative, or a strong negative. So now we're going to look at an example of how we can find our correlation coefficients, and then we'll be able to determine the strength of the data just from that. All right, so now let's look at example one. In example one, it says, what is the approximate correlation coefficient when the data set below is represented by a linear best fit model? So in order to find correlation coefficient, we're going to start off with a table. And the way we get our table is hitting the plus sign and selecting table. Then we're going to enter our data into that table. Now, if it's a scatter plot, we got to estimate the points. If it's already a table given, we just enter those point values exactly the way they are. And then we're going to hit the add regression. Remember that your add regression button is aligned with some dots around it. And that pops up when you finish filling in your table. So we're going to type in or fill in the spots where our point should be. So we got 1, 2, 5, and 7. We have 12, 10, 8, and 4. And when we do that, we hit the regression button, and we're going to be looking for a linear regression for this question. Now, with the linear regression, what you're going to see is a whole bunch of data that shows up, like the equation, statistics, and residuals. Now, we're not going to use residuals yet. We used the equation already, but we're just going to write it down so we just have it. So that was y equals negative 1.2x plus 13.0. But what we really need is under statistics. There are two values underneath statistics. One is r squared, and the other one is the r value. Now, based off our definition at the top, r value is the correlation coefficient. So the r value for this problem is going to be negative 0.9746. Using that number, we're going to go back to our number line. Remember that depending on what the number is and where it falls, it'll be one of these options, whether it's strong positive, moderate positive, weak negative, moderate negative, or strong negative. Now we had a negative 0.9746. So that number, if we really look at it, is really falling close to -1. And when it falls closer to 1, it becomes stronger. So if we look at it, it falls within the range of negative 0.9 and -1. So this one will be a strong negative for the answer, for example, 1. So we got strong negative. So now let's move to example 2. In example 2, it says the table below shows the number of floors and height of 4 buildings in a city. What is the approximate correlation coefficient of the line of best fit for the data? So when we start to solve this problem, we already know what we're looking for because they told us we need the correlation coefficient. All right, we're looking for the line of best fit. So let's enter our data. So we go to Desmos, hit the plus sign, hit table. Our first row is 24, 27, 28, 30. Our Y values are going to be 246, 277, 282, and 296. Now once we hit that, we hit regression, and it's going to be a linear regression. Now what we're looking at is our R value. So when we look at it, we're going to look at equation they gave us. Under statistics, we have two R values. We have R squared and R. We don't want R squared, so we're going to get the R. The R value that they provided us with was R equals 0.9908. Now we're going to go back and compare that to our chart. But remember, the closer to 1 that it is, the stronger it is. Now, if we look at this like money, this is 99 cents actually. So 99 cents is actually close to $1, right? So that means from that, what we're looking at, we still have a strong, and this one is a positive number, so it's going to be a strong positive. Now to answer the question, we got 0.9908, and the answer for this one will be answer choice D. Okay, so now let's move to example 3. All right, it says in example 3, it says which best describes the relationship between time a student spends studying and their test score. So we're going to start fresh on our Desmos, clear everything out, hit plus sign, bring up a table. We're going to enter our table of values. So we have 25, 0, 10, 30, 60, and 75. Then we have 77, 72, 80, 85, 96, and 98. Now, once we get that, we make sure we hit our add regression, and we're going to go from there. Now, we're looking for the R value. The R value in this one they gave us was R equals 0.9594. So looking at that R value, we already can tell that it should be positive because the number is positive. And then we go back to our chart to compare where it falls, whether it be strong, moderate, or weak. And then we can tell what our answer should be. We already know that it's going to be a positive. So if we look at our 4 choices, we can mark out anything that's with a negative attached to it. So is it strong or is it weak? Now, the closer to 1 that it is, the stronger it is. The closer to 0 it is, the weaker it is. We're looking at 0.9594. Now, if I say 0.95, if we look at it like money, it's still 95 cents. 95 cents is closer to $1 than it is closer to no dollar. Okay, so that means it's going to be a strong pop. Now we can move on to our last example. In example 4, it says the table below shows the dosage of medicine a person should take based on their weight of the person. Which best describes the correlation between the dosage a person takes and the person weight? So when we go to Desmos, we hit the plus sign table, type in our table of values. So for the X side, which is weight, we have 100, 120, 150, 175, and 190. For the Y side, we have dosage, which is 50, 75, 100, 125, and 130. Then we hit add regression, and then we can get our R value. So the R value that we have for this question is going to be 0.9931. So looking at answer choice A says that we have a strong negative correlation. Answer choice B says we have a weak positive correlation. Answer choice C says we have a strong positive correlation. Answer choice D says we have a weak negative correlation. Now looking at the R value that they got. So with this R value, we can tell that it's going to be positive. So that's one thing that we know just by looking at the number. Now let's look at the strength of it. The strength of it, this one is 0.99, closer to 1, so it's going to be considered to be strong. The closer to 1 it is, the stronger it is. The closer to 0 it is, the weaker it is. So we're looking at an answer choice that needs to be positive and strong. And when we look at that, the answer that we get is going to be answer choice C.